Lesson 1-4 is on solving proportions. I'm going to complete lessons 1-4 and 1-5 on the same video because they're very similar. Lesson 1-4 is solving proportions primarily with numbers. And then lesson 1-5 is using word problems along with geometry. Okay. And we're going to learn how to set up a ratio and a proportion, which I think will help you with what you are currently doing in science. Hopefully. All right. So whenever you are solving a proportion, you are going to use a property called cross product. And that means that you are going to multiply across. Okay. And when you multiply across, you should have two equal sides. So let me show you what that means. When I take, let me get my pencils here. When I take 3 times 10, I get 30. Okay. And when I set that equal to 5 times 6, see how we're multiplying across? Multiplying is we're taking two products. That's what we call it, the cross product. This equals 5 times 6, which is 30. Now, what you actually have here are equivalent fractions. That's what proportions are, equivalent fractions. All right? Just reduced or multiplied by a greater factor. So let's look at the steps to solving a proportion. So I want to know what x equals. Okay, I'm going to move this down just a little bit further. Okay, so what I'm going to do is I'm going to cross multiply. I'm going to use the cross product property and I'm going to cross multiply. So let's do that first. Our first one is 7 times 12 equals 8 times x. Now you could skip this step and you can go ahead and just write this step. 84 equals 8x. Okay? You're multiplying the 12 and the 7. I'm sorry, yeah, the 12 and the 7, and then you're multiplying the 8 and the x. Okay? So then, in order to figure out what x is, I have to divide both sides by 8. Oops. Okay. All right. We know that these cancel out. And then 84 divided by 8 is going to end up being a decimal. Remember, I don't want decimals, so we're going to reduce the fraction. And we can reduce it by dividing both the top and the bottom by 4. Okay. Yeah, 21 over 2 equals x. And that's your final answer. 21 over 2. Yep. Sorry. All right. So that's pretty much all you're doing. Let me show you another way that you can do it that's a little easier. And this is something that I would actually try first. If these are equivalent fractions, what did we do to the, oh, I'm sorry. What did we do to the 4 to get the 8? Multiply by 2. So all we have to do, if we multiply the top by 2, we multiply the bottom by 2, and x equals 6. Yes, you did. Okay. So wait. So this would be our answer. Now, why would I choose to do the cross product instead of just finding equivalent fractions? Right. If you look at this, do we know off the top of our head what 8 times something is to get 12? No, so then that's when we'll want to use the cross products. But if you have something simple like this, you will show your work on your homework by showing what you're multiplying the top and the bottom by. Okay? All right, we're going to move down to example 3. On 3, this is similar to some of the problems you had to do on lesson 1-3 where you had to multiply by a binomial, which is a term with two terms. It's an expression with two terms. All you're doing is you're multiplying 4 times b minus 8, and you'll write it like this: 4 times b minus 8. Okay? And then you do the same thing with the other cross product, equals 5 times b plus 3. Now you're going to solve this like you would a multi-step equation. You're going to use the distributive property. Then you're going to put all variable terms on one side, all constants on the other, and then you're going to use the inverse property to find what b actually is. Okay, so the first thing we're going to do is distribute the 4 to both terms and then distribute the 5 to both terms in each parenthesis. So 4 times b is 4b. 4 times -8 is -32. Equals 5 times b is 5b, and 5 times 3 is 15. From this point, this is exactly what you did in lesson 1-2, and you should be able to solve this. What I'm going to do is I'm going to subtract 4b on both sides. Okay. And I'm left with -32 equals b plus 15. And then I need to subtract 15 on both sides. And -47 equals b. All right. Any questions on that? All right, I want you all to do example 4 on your own, and then we will check it. So I'm going to pause the video. When we come back, we'll have the answer on the screen. All right. So this is what you should have gotten for example 4. Yay. Okay. Yes,
What if we got it, but we just did something different? Like,
that's fine.
I didn't.
Yeah, I mean, sometimes there's multiple ways to do this. So as long as you got the correct answer, you're good. Okay, number 5, last question on lesson 1-4, and then we're going to move straight to 1-5. A portable media player has 2 gigabytes of storage and can hold about 500 songs. A similar but larger media player has 80 gigabytes of storage. About how many songs can a larger media player hold? And we are assuming that they are proportional. Okay, so we have 2 gigabytes and 80 gigabytes. And then we have 500 songs and how many songs? Okay, so when we set this up, we're going to set up gigabytes to gigabytes, set equal to songs over songs. So this one is going to be the portable, okay, over the larger, okay? And then on this proportion, I'm going to have gigabytes. So I'm just going to put gigs. And this is going to be equal to songs, okay? So if this confuses you, you do not have to set it up this way. But let me show you what I'm actually doing. I'm going to take 2 gigabytes over 80 gigabytes. So 2 over 80. Notice how this entire fraction is gigabytes. but I have the portable gigabytes over the larger player gigabytes. Now I'm going to do the songs. How many songs does the portable player play? 500. How many songs does the larger one play? We don't know. Yeah, we could put X, you could put Y, you could put J, you could put Q, you could put whatever letter you want. So now we're going to use what we know about solving proportions to solve this problem. You could solve this either way. You could use equivalent fractions, or you can use the cross product property. So I want you to try to solve this on your own, and then with your partner, I want you to check it. Okay? So I'm going to pause the video and we'll come back and check the answer to this one. Okay, so there's two ways you could do this. Most of you could see that 2 times 250 is 500. So then you would multiply 80 times 250 and you would get 20,000 is X. Or you could have said 2 times X is 2X equals 80 times 500, or yeah, 500 is 40,000. And then divided both sides by 2 to get X equals 20,000. Either way works. Now, this is not your answer that I want to see on your homework, and some of you are not putting the units, but your final answer should be 20,000 songs. That's your final answer. Okay? So that is lesson 1-4. Any questions? Okay, we're going to move on to lesson 1-5. So there's only 4 questions, but the difficulty with this is the ability to set up a proportion. So this one is proportions with similar figures, such as 2 triangles. Okay, so figures are similar or proportional if their corresponding sides are proportional, meaning their corresponding sides are like equivalent fractions. So for example, if I wanted to figure out what X is on this triangle, I have to set up a proportion with equivalent fractions. So I'm going to do something up here that might help us work this out. So AC on this triangle is equivalent to DE on this triangle. So if I were to set up a fraction here, I could set up 21 over X. Okay? Because these sides are proportional. Then I have AB and DF, which are proportional. So I would set this up equal to 15 over 10. Now, I want you to understand that when we're doing similar figures or scale factoring, that it's important the way that you set it up. Notice I have the big triangle over the small triangle. So big over small. Okay? Oh yeah, I'm sorry. There you go. Big triangle over small triangle. 21 over X. And then I took big triangle over small triangle. If I were to flip this, if I had big over small, but then over here, small over big, my proportion's wrong. Part of this lesson is being able to set up a correct proportion. So even though you might be able to solve these in your head, you must set up the proportion and solve it the way I'm teaching you, okay? Can somebody tell me why I did not use CB and EF? Elijah?
On E, it doesn't say.
Yeah. EF doesn't have a number. It doesn't have a value. Okay. So I couldn't use EF. Okay. So I am going to find X. This is what I'm looking for right now. So all I'm going to do is I'm going to make equivalent fractions and solve for X. Now, can I use equivalent fractions or do I need to use cross product? Cross product. So I'm going to multiply 21 times 10. I get 210. And then X times 15 is 15X. All right. And then I'm going to divide. Okay. And you would think, oh, these aren't divisible, but they are. What is 210? 14. Now, we don't have units, so I'm just going to put 14 units equals DE, side DE, okay? That would be your final answer. So if you put 14 equals X, make sure your final answer looks like this. DE means side DE, okay? Now, what I want you to do is I want you to find Y over here. So we know that X over here is 14. I want you to set up a proportion and I want you to solve for EF, and you could do that over on the other side of the triangles. Now, it doesn't matter if you use blue and green or orange and green. Okay.
Wait, why are you talking about color?
The way that I highlighted them. Okay. So I'm going to solve mine over here. When you're done, you can look up here to make sure you got the right answer.
Do we have to have a line over the EF?
Yes, that shows that you're talking about a side.
What if we don't put it on our?
Not right now. No. Yes. No. Usually it's in alphabetical order. So one thing I want to show you right here, and I think this is on your homework. Yes.
Oh, this isn't actually about the horn, but it's about that. On 1-1, I already gave it to you, but I didn't know like we had to put anything. I put dollar signs on some of my answers, but
I'll talk to you about it after this. Okay. So whenever you're talking about equivalent sides and angles, I'm going to show you how to write them. So notice 20 AC and DE are highlighted. You would write this as AC is equivalent to DE. Okay? So these are sides. I would write this down. And then AB is equivalent to DF. You guys see what I'm doing here? And then BC is equivalent to what? EF. Okay?
yeah,
Yes, that means equivalent to.
I don't get it.
Okay, this side right here is equivalent
Okay, never.
to this side, or proportional. I should be saying proportional to this side. All right, now let's talk angles. Angle A, you write it like this, angle A is proportional to angle D. And that's just the symbol for angle. Angle B is proportional to angle, what? F. And angle C is proportional to E. There you go. There's going to be one or two problems like this on the homework that's going to ask you to show this, okay? So we're going to skip the things to note because I've already talked to you about it up here, and we're going to go down to example 1. It says draw the following triangles, triangle ABC and triangle DEF. Now notice that A comes first, then B, then C. That means that angle A and D are going to be proportional, B and E are going to be proportional, and C and F are going to be proportional. So they have to be on the same side of the triangle. So we're going to draw 2 triangles. Now the numbers are a little bit off. So, oh, yep, thank you. I'm going to make 2 triangles. A, B, C. And then I'm going to make another one that's a little bit bigger. And that's going to be D, E, F. Okay. So I have A and B and D and E. Yep. Let me get this still. There we go. And then I have A, oops, A and C and D and F. So I'm just drawing my lines to help me set up my proportions correctly. You do not have to do this. It's just something that could be a tool for anyone who needs it. Okay, so those are my proportional figures. Now, it tells us that AB is 8. So I'm going to put 8 right here. It tells me that BC is 12. Okay. It tells me that DE over here is 12. I need to change these numbers. And it tells me that DF is 18. And it wants me to find the value of EF. So EF is over here. I need to find this value right here. Now, there are multiple ways that you can set up this proportion. Okay. But notice that on the first triangle, we only have 2 sides with numbers. So we have to use AB and DE, which are our equivalent sides. And we have to use BC and EF, which are our equivalent sides, basically the blue and the green highlights. Yes.
Does it matter if I put my A on top, instead of my B on top, and just like shift it all?
As long as it's DEF. Yeah. Okay, so I'm going to start off my proportion with my first triangle. It's going to be 8 over 12. And then my second triangle is 12 over x. Now, that is not the only way I could have set it up. I could have also set it up as small triangle over big triangle, 8 over 12. Oh, it will be the same thing. Because of the way the numbers are. I need to change some of my numbers, but that's okay. All right, so I want you to go ahead and solve the proportion to find what x is. Okay, check your answer up here when you're done. Any questions? Anyone still working? Yeah.
How was I don't know. If like the bottom is 18, the side is 18. Those are the same, but then 12 is not. So does that mean that A and C is 12 too?
The numbers are not, I need to change the numbers on my notes. The numbers are just off. So as long as you're able to solve the proportion, I need to change this up a little bit. Ari?
I can decide which number's on top and which one's.
So you have to have the proportional sides. So you could have the blue sides small over big, and then the green side small over big. Or you can have the small blue over green, and then the large blue over green. So either way you can set it up. Again, these numbers are just, it makes it a little bit challenging.
Oh, yeah.
Either way, yeah. I need to change these. Brady,
Said big over small.
big over small, or the colored sides over the colored sides. Either one, it doesn't matter.
But the order we do.
It matters the order as long as you're using proportional sides or the same triangle over the other triangle. Okay. Let's flip it over and let's do example 2. It says the sun's rays strikes a building and a girl at the same angle. The girl is 5 feet tall and casts a shadow that is 3 feet long. The building casts a shadow that is 5 feet long. Okay,
50.
I'm gonna draw. I do images. So I'm gonna draw a little girl. Okay. And she is very cute. Okay. And she's very happy. Okay. She is how many feet tall? She is 5 feet tall. And how far is her shadow? 3 feet. Okay. And our beautiful sun is coming from this direction. Do you really need to draw? No, but you know, it's fun sometimes. It actually helps you to see what's actually going on.
Why is the 3 feet longer than the 5?
That's what else is.
I don't know. All right, then you have a building. That's a little crooked. Here's my building. How tall is my building? Okay, it is, oh wait, we don't know how tall the building is. How tall is the building? This is going to be X and the shadow is 15 feet. Okay, now this is a better one to go off of to see how to set up the proportion. There's different ways you could do it. You could do the girl's height over the girl's shadow and the building's height over the building's shadow. Or you can do the girl's height over the building height and then the girl's shadow over the building shadow. Yep. So you can do either way. So I'm going to do girl over building. Okay. And I'm going to do height and shadow. Now you can set it up the other way if you'd like, but let's figure this out. So we have the girl's height, which is 5, over the building's height, which is X. And this equals the girl's shadow of 3 over the building shadow of 15. You can use the cross product property.
Oh,
Whenever we finish our answer, what do we put? Do we just put X?
So no, you would put
I know, like,
25 feet tall.
you don't put equals.
I mean, you could if you wanted. You could put X equals 25 feet tall if you wanted to. Can somebody tell me another way? Okay, I see. Hold on just a second. I'm going to answer some. So another way that you could set it up is height over shadow and then the girl's proportion and the building's proportion. You will end up with the exact same answer.
I did what she did. I did a height over equal shadow.
Okay, and that's fine. The only thing that you can't do is you can't take the height over the shadow of the girl, but then flip that and put the shadow over the height of the building. You can't flip it. Just like over here, you can't take the height of the girl over the building here, but then the shadow of the building over the girl here. You can't flip it. Okay, there was the question asked, can you cross simplify these? And the answer is no, that is with multiplying fractions. So you use the cross product and you multiply them together, but do not cross simplify. Okay, if you do that, you're going to end up with the wrong answer and that it does not represent a proportion. All right, let's go down to example 3. A map has a scale of 1 inch to 110 miles. So I'm going to do inches over miles. Okay. So this is the scale. The map indicates that the distance between Jacksonville and Orlando is 1.25 inches. What is the actual distance? It's asking for the actual distance. So if the scale is 1 inch is 110 miles, then the actual, to figure out the actual, it's going to be inches, 1.25 inches over a certain number of miles. Okay? Does that make sense, what I just did? I'm taking inches over miles on the scale and then inches over miles for the actual. Now go ahead and do your cross product property and figure that out. And then when you're done, check your answer. Okay. And the other way that you could solve this is you know that 1 times 1.25 equals 1.25, then you can multiply 110 by 1.25 and you'll get the same answer. Okay? So, and then this is the way I want you to write your answer. Okay. Moving on to example 4, I'm going to get you started on this one and then I want you to solve it on your own. It says a giant model heart is 13.9 feet in length. The heart is the ideal size for a person who is 170.3 feet tall. Obviously, this is a giant model, just like it said. About what size would you expect the heart of a man who is 6 feet tall to be? Now, in Bible class, oh no, it wasn't in Bible. I think it was study skills. Is anyone in here in study skills? And Mrs. Mora told you what the size of a human heart is. Did she tell you what to do to figure out the size of a human heart?
That's brain.
I mean,
Isn't it your fist?
oh, that is your brain. Oh my gosh, you're right. Okay, I was thinking brain.
This last.
But what?
The size of your fist.
Yeah, the brain is. But your heart.
Yes.
That's her brain.
Yeah, I think. Okay, ignore that analogy. Okay.
I think your brain is.
Okay, I am recording, so it'd be nice of you to. All right. So what I want you to do with your partner, I want you to try to figure out how to set up this proportion, and then we'll come back and check before you solve. So go ahead and do that now. These are the 2 different ways that you could have set up the problem. You could have done the model heart over height and the person heart over height, or you could have done the size of the heart, which is 13.9 over x, and the height 170.3 over 6. Either way, you're going to get the same answer. So when I solve this, I get 170.3x equals 83.4. And I'm going to explain this in just a minute. So we divide both sides by 170.3. Hold on, guys. You're going to get some very long answers. So 83.4 divided by 170.3. You're going to get this very long answer right here. Point. And this is the answer that I would say is about 0.5 feet tall. Now, if you think about it, half a foot is 6 inches. So 6 inches is about the size of a heart of a man who is 6 feet tall. Doesn't that make sense?
What? Wait, does that mean like a 1 foot baby would have an honest heart?
Yeah. Yeah, your heart grows with you. Okay. Okay, so there's 2 ways to set up the proportion. Either way is going to get you the same answer. And so that actually concludes both lessons 1-4 and 1-5 on proportions. All right.